So the intent of this video is to show you how to use an Arduino UNO board to blink an LED in different sequences. To start off, we have an Arduino UNO board with an LED blinking on it, plugged into a computer using the supplied USB cable, and the computer is running the Arduino editing software. So that's basically all you need. The board, an LED, the USB data cable, and a computer with the Arduino software. The Arduino software can be downloaded from the Arduino website, and I can put a link for that in the description. So just to kind of get an idea of what's going on here, basically I've already uploaded software, some code that I wrote to the Arduino board to make this LED blink on quickly, off quickly, on quickly, and then it stays off for a little longer, and then it repeats. And it'll keep repeating this. We'll go over this as soon as we're writing the code. It'll keep repeating this until I turn off the board. So if I were to unplug the USB right now, the LED would stop running because that's what's powering the board. However, if I was to plug a 9 to 12 volt source into here, the board would come back on, but I would not be able to link any code to the board. So basically, let's zoom in here. There we go. So you can see the two legs on my LED right here. One is going into it looks like it's going into the AREF port, but it's actually going into the ground. Let's come over top of this so we can see better. Yeah, that's going into the ground port, the GND, and the other leg is going into, it looks like, the 11 port. So I have my Arduino set up right now to output power to the 11 port at a specific sequence, and we'll go over that in the code, how we tell it to do that. So basically we're only going to be dealing with this the right side here of the Arduino board, all these pins here, 0 through 13 and GND, and ultimately we're going to be dealing with GND and pin 12. So pin 12 will be our output, and ground will be the negative input. So if I take this LED out, it's going to stop blinking, of course, but if you look at the legs of it, one's a little longer than the other. Typically that signifies the positive end of the LED, where the short leg is the negative. If not, you can get a simple little tester and put it in. If it works, great, you have it oriented right. If not, flip it around and see if it works then. For one LED, you probably want no more than 3 to 5 volts. Otherwise, you'll burn it out. 3 is probably best. 5 might be a little high. Now, if I put this LED in, the long leg this is how I had it. If I put it in, the long leg in the ground port and the short one in the 11, nothing's going to happen. So if I flip it around, short leg in the ground and long in the 11, boom, it's back on and working. So that's kind of basically how this works. You can also link a series of different LEDs using some jumper wires to a breadboard or a circuit that you've put together, and do the same thing. The reason we're skipping over pin 13 is because 13 controls the little orange LED light on the Arduino board. You can do the exact same thing with these two lights. In fact, in the code, I'll show you that if you set both of them to do the same thing, they'll both do the same blinking sequence. So you don't actually need an LED. The orange LED is there for you to experiment with. However, let's use this white one because it's much brighter and cooler. So let's go ahead and take out the LED. power off the Arduino. We'll take everything apart so we can do this from the beginning. So, from the beginning, as we said, what we're going to do is we're going to plug the Arduino back in. We will plug it into the computer. That gives us power. You can see the orange light blinking, telling us it's turning on, and then the green light over here says on. So we're plugged USB into the computer, and our LED is out. So let's just assume there's nothing uploaded to this Arduino right now. In fact, we're going to be uploading our code using pin 12 as our output. So there's nothing on pin 12 right now. I don't think. Let's check. So if I plug into the ground and pin 12, I should get nothing, which I get nothing right now. So we'll go ahead and leave the LED in there so that when we upload our code to the Arduino, we can see what's going on. So the next thing you want to do is move over to the computer. Alright, so now that we have the Arduino software open, if you don't already have a blank sketch, you can just go ahead and go to File and create a new sketch for writing your code. However, if you already have one looking like this, we're going to begin our code by setting pin 11 to an integer LED. So basically, we're going to create an int called LED, and we're going to set it to pin 12. So that's telling us that our LED is at pin 12. That's also telling the Arduino that our LED is at pin 12. The next thing we're going to do is the second part of 3 parts of this little program that we're going to write. We're basically going to write the setup, which is a void method. So there's no return value. It just sets up our Arduino to run the code that we're writing on there. So what we need to do is we need to declare what type of pin LED is. So we're going to use the pin mode method, and we're going to say pin mode of LED, which is also pin 12, is going to be an output pin. So pin mode LED, and then we're going to call it output pin. So we have LED as an output, and that's all we have for setup. So what's going on in here is we're just going to go ahead and write in a comment here, so we know what's going on here. So the next thing we're going to do is we're going to write our loop. This is what is going to be controlling the LED, and it's going to be looping around and around infinite times until we turn off the Arduino. So we're going to do a void loop, and inside the loop we're going to basically tell our LED what we want it to do. So in this case we want to write out to LED, so we're going to use the digital write method, and we're going to write to pin 12 or LED. So we're going to digital write LED, and we're going to put it on high voltage. So what this is going to do is it's going to turn our LED on high voltage, which will turn on the LED. So at this point, if we verify our code, so we're going to compile, hopefully it likes it, good, and we're going to run our code by uploading it to our Arduino. We have to have the USB cable plugged in. When we upload this, you're going to see on the Arduino board a couple orange blinking lights saying that's basically telling us that the information is being uploaded, and then they'll stop and the LED will start blinking. Well, in this case it should just stay on. There we go. So our LED is on. So now what we want to do is we want to turn our LED off. So we're going to write to the same pin. We're going to do a digital write, and we're going to do pin LED, and we're going to say low. So this is going to put low voltage into the LED, essentially turning it off. So what we're going to do is for now we're going to start by verifying our code and compiling it, and then we are going to upload it to our Arduino, and what's going to happen is our light is actually just going to stay on. This is because we haven't told the code when to turn on and off. So what we need to do is we need to tell our LED how long we want it to stay on using the delay method. So we're going to say delay, and we're going to specify an amount of time, and this time is in milliseconds. So 500 is going to be 500 milliseconds, which is about half a second. In fact, it's exactly half a second. And so we're going to try that. Still, this isn't going to work. Our LED is just going to stay on because we haven't specified how long we want it to stay off. Because this is a loop, we're going to go high for half a second, and then low, and then high again with no delay. So we need a delay in between the low and the high, well, after the low, because we're going to re-loop through and go back to the high. So we're going to delay about the same, 500 milliseconds. So now we should have an LED blinking on and off, on and off, on and off, repeatedly, forever and ever and ever and ever, well, until we, unplug it from the computer. So basically, here you have your blinking LED, which is really pretty cool. You can play around with it and change the times around. Let's say 200 milliseconds for each of these. It'll blink a little faster. And then we can copy that and let's do kind of a blink, blink, off, blink, blink, off. So we have a quick blink, quick off, quick blink, longer off. It'll be kind of a cool little sequence that we can try here. So you can see that you're having the blink, blink, off, blink, blink, off, and pretty cool. So, I mean, we can keep playing around with it a little bit, changing it around, make it blink faster, slower, things like that, and we should have a lot of fun.